Did the Toba eruption cause a population bottleneck in modern humans? No one alive today has witnessed a volcanic eruption remotely as big as the Toba super eruption, but our ancestors may have done so tens of thousands of years ago when northern Sumatra exploded, creating a caldera now filled by the largest volcanic lake on Earth, measuring 60 miles long by 20 miles wide and up to 1/3 mile deep. Indeed, the Toba eruption changed the world. It might have been the closest brush our species had with extinction, but we have no memory of this traumatic event. For 6 long years, small bands of humans clung to survival as the Earth froze and ash blotted out the sun. With no sunlight, most of the planet's plant life had died off. What was left were just a few thousand humans who survived in isolated pockets across southern Africa. Later, after their populations had recovered sufficiently, these pioneers headed out of Africa and repopulated the rest of the world. At least that is the story we have been told. But when, exactly, did this eruption happen, and what were the consequences? In a paper published in the Proceedings of the National Academy of Sciences, researchers have pinned a date on the Toba super eruption. It happened 73,880 years ago, with an uncertainty of just 640 years, a 95% confidence. This mega-colossal eruption was the third and largest in the last million years at Toba, and the most explosive on Earth for more than 2 million years. More than 7 trillion tons of volcanic material were ejected, of which at least 200 cubic miles was spewed as ash across the Indian Ocean and the adjacent land masses of South and Southeast Asia, covering several million square miles of the planet's surface in debris. The super eruption would have caused spectacular atmospheric phenomena, including auroras, red sunsets, and other unusual visual and meteorological effects. The massive release of volcanic ash and aerosols, particularly sulfate aerosols, into the stratosphere scatters sunlight. This scattering enhances longer wavelengths, reds and oranges, during sunrise and sunset. Fine particles in the stratosphere would create vivid, prolonged red and orange sunsets and sunrises. These phenomena could last months, as aerosols remained in the atmosphere and continued to scatter sunlight. Volcanic ash containing fine particles can scatter red light, making the moon appear bluish. Ice crystals and volcanic aerosols in the atmosphere might have created halo-like effects around the sun and moon. Humans witnessing dramatic sunsets, strange colors in the sky, or prolonged twilight might have interpreted these phenomena as ominous or divine, potentially influencing mythologies or survival behaviors. Superheated clouds of gas, ash and rock may have traveled up to 100 kilometers from the eruption site, incinerating everything in their path. The super eruption would have generated local and regional tsunamis due to pyroclastic flows entering the ocean, caldera collapse, and associated earthquakes. These tsunamis would have devastated coastal ecosystems and human populations. While direct geological evidence is scarce due to the age of the event, analogies with more recent eruptions strongly support the likelihood of tsunami generation. Paleoclimate models suggest that the ejecta, both the dust and gas, moved rapidly to the northwest. This deadly cloud of debris enveloped the northern hemisphere of the planet, bringing about the scenario described above. The climate impact would have been rather negligible for the sub-equatorial regions. This all occurred as the planet was entering a cooling phase, and inevitably the supervolcano accelerated the climate shift. It now seems there was already a low effective global human population, and it is hard to know how much further Toba lowered the numbers of Homo sapiens. What must be contested here is that all of these early humans were in southern Africa, but this goes against the archaeological evidence. We have pre-Toba modern humans, fossils and tools associated with our subspecies distributed across the Levant, China, Indonesia, and potentially even Australia. The bulk of the existing genetic and physical evidence now runs directly counters the popular consensus hypothesis that a post-Toba African founder population went on to repopulate the world beyond. The conventional timeline of human evolution and migration continues to crumble in the face of new research. The latest finding puts anatomically modern humans deep in Asia at least 100,000 years ago, tens of thousands of years before once thought possible. The old timeline, still widely taught, went something like this. Homo sapiens evolved into a distinct species from earlier hominids about 200,000 years ago in Africa and became anatomically modern humans about 100,000 years ago. Then, around 50,000 years ago, they headed out of Africa and spread through Eurasia, replacing Neanderthals and Denisovans. This makes sense, except for all that pesky, confounding evidence that continues to emerge. Just recently, for example, both paleoanthropological and paleogenetic discoveries have pushed back the start date for Homo sapiens, in some cases by hundreds of thousands of years. Archaeologists lament that there is not enough evidence in the archaeological record to tell just what was happening at around 74,000 years ago. But a highly compelling study in Nature found evidence of humans in northern Australia by about 65,000 years ago. That's about 15,000 years before modern humans supposedly left Africa, if you're keeping score. The researchers dated more than 10,000 artifacts from Majidbebe, a site not far from the modern coastal city of Darwin, Australia. Indeed, the theory that the Toba eruption almost brought humanity to extinction is becoming less supported. It rather seems that we already had low population levels due to a bottleneck event closer to 130,000 years ago, and that the bottleneck event recorded in the non-African genome relates to the ancestral migration of only a small number of modern humans into Eurasia around 60,000 years ago. Furthermore, researchers who studied sediment cores taken from Lake Malawi believe they found no evidence of a plant die-off that would have come with the 6-year-long nuclear winter that is proposed to have happened in the Toba catastrophe theory. Lake Malawi, also known as Lake Nyasa in Tanzania and Lago Nyasa in Mozambique, is an African Great Lake and the southernmost lake in the East African Rift System, located between Malawi, Mozambique and Tanzania. This only confirms what should have been assumed right from the moment the paleoclimate models revealed that only the northern hemisphere would have suffered a nuclear winter. It should have been no surprise to find that sub-equatorial regions were only moderately affected. All non-African populations have a bottleneck during this time, but it is most probably due to the migration out of Africa. The Toba eruption might have added to this bottleneck. We just don't know. The Lake Toba eruption at 74,000 years ago is so close to the time that Eurasia was repopulated, approximately 70,000 years ago, that it is easy to see how the margin of error would allow the event to be confused with the bottleneck caused by migration into Eurasia. Consider that one leading geneticist calculates that the migrating population numbered only around 200 effective individuals, a number that has been supported by several recent studies. Nevertheless, little useful data is available on the full impact the Toba eruption had on hominins, including modern humans, living in the northern hemisphere. We can certainly infer that they had a bad time, because by the time most of Eurasia was repopulated, the continent was almost empty, and within about 20,000 years of the migration starting, there were no other hominins remaining on the continent. While the direct effects of the Toba eruption in Europe are still debated, it is believed that the eruption caused global cooling and disruptions to ecosystems which would have affected Neanderthal populations. Nonetheless, several Neanderthal sites, including Krapina and Vindiga in Croatia and Arcy-sur-Cure in France, provide evidence that Neanderthals were largely unaffected by the Toba eruption 74,000 years ago. Occupation layers show Neanderthal presence during and after the Toba eruption, suggesting resilience to climatic fluctuations. Neanderthals in temperate Europe seem to have adapted to the post-Toba cooling, highlighting the adaptability of Neanderthals to harsh climates. This is especially relevant when we consider the lack of any sustained efforts to understand what was happening to modern humans in Eurasia. We also know that humans were living in North Africa and the Levant prior to Toba. So what about these people? The Monte Epomeo eruption in the Bay of Naples, Italy, occurred between 50,000 and 55,000 years ago. This volcanic event had a volcanic explosivity index of 6, categorizing it as a major explosive event capable of regional devastation. The eruption released an estimated 10 to 20 cubic kilometers of volcanic material, primarily in the form of ignimbrites, pyroclastic flows, and ash fallout. The fallout from this eruption affected a broad swath of southern Italy, with ash layers reaching mainland Europe. A second eruption, the Pantelleria Green Tuff eruption, occurred around 45,000 years ago on the island of Pantelleria, located in the Strait of Sicily. With an explosive index of 6 to 7, this eruption ranks among the largest in the Mediterranean during the late Pleistocene. The event was characterized by the explosive ejection of 80 to 100 cubic kilometers of pyroclastic material, including vast deposits of ignimbrites. Nonetheless, the most significant event during this epoch was the Campanian ignimbrite eruption. This eruption was the largest in Europe during the late Pleistocene, ejecting hundreds of cubic kilometers of ash and pyroclastic material into the atmosphere. The eruption blanketed much of Europe and the Mediterranean with ash and pyroclastic flows. Tephra deposits have been found as far afield as the Black Sea, Russia, and the Middle East, demonstrating the scale of the event. Southern and Eastern Europe were particularly hard hit, with thick ash layers covering habitats. In southern Italy, pyroclastic flows and ignimbrites obliterated local ecosystems, leaving the landscape uninhabitable for years. The Campanian ignimbrite eruption, centered near Naples, occurred approximately 39,220 years ago. This eruption had an explosive index of 7, indicating a catastrophic explosion. The eruption released an estimated 300 to 500 cubic kilometers of volcanic material, making it a super-eruption by modern standards. The climate effects of these eruptions, while less severe than Toba, would have included temporary cooling caused by the release of sulfur dioxide into the atmosphere. This cooling, compounded by the already harsh conditions of the last glacial period, stressed ecosystems in the Mediterranean. The ashfall and pyroclastic flows would have destroyed vegetation and limited food availability, forcing humans to adapt or migrate. Furthermore, several other volcanoes erupted in quick succession around 40,000 years ago in the Caucasus Mountains, which span the region between the Black Sea and the Caspian Sea. Mount Elbrus, a stratovolcano, and the highest mountain in Europe at 5,642 meters, or 18,510 feet, was the biggest culprit. Nearby, Mount Kazbek, at 5,047 meters, or 16,558 feet, also erupted around this time, possibly along with several lesser volcanoes in the region. The conviction that human populations were not impacted significantly by these eruptions is based on the invalid assumption that all Homo sapiens lived in sub-Saharan Africa at the time of the eruption. We have archaeology placing modern humans in the Levant, Middle East, India, China, Indonesia, and possibly even Australia prior to the Toba eruption. The Ungandong skulls of Java, which are morphologically related to the Omo skulls of Ethiopia, places archaic Homo sapiens in Indonesia 107,000 years ago, and most of the additional evidence is associated with the period 80,000 to 120,000 years ago. It was a time when these early humans went through a bit of a renaissance. They began decorating themselves, beads, manufactured poisons, and developed bow and arrows. With these new technologies, they began their long march out of Africa. This sudden technological and cultural change, indeed advancement, should be a red flag that something else is going on here. If sub-equatorial Africa is not being radically impacted by the Toba event, what is the tenuous link between a perhaps very slight cooling of the climate and such a radical shift in human culture? It sounds almost as though humans have arrived that had a very different culture involving body adornment, unique plant knowledge, and highly advanced weaponry. This sounds like cultural diffusion, not a renaissance. Why would these people who are safe in sub-equatorial Africa move northwards into a cataclysmic climate and environment? 3 recent climate studies have deduced that from 73,000 to 59,000 years ago, North Africa, the Levant, and the Middle East were deep in the most extreme drought ever detected in those regions. Any attempt to exit Africa by land would have been a suicide mission, and one must wonder what is the driving force that makes humans leave green pastures for barren wastelands. It is not reasonable and logical, therefore the default assumption should be that it did not occur, and so far no solid evidence is found suggesting it did. In the human genetic record, this migration might explain that bottleneck. It is known as the founder effect, where a smaller group of individuals break from a larger population, and this causes a loss in genetic variation. Now we come to the most important part of this discussion, analysis of the genetic record and the divergence of a founder population responsible for repopulating Eurasia. Every mainstream genetic study dates the start of the populating of Eurasia at between 60,000 to 50,000 years ago, with a strong pull towards 55,000 years ago. There are no mainstream studies that dates the divergence of the first Eurasians to anywhere around 70,000 years ago. That earlier date is always given for reasons of dogma associated with existing consensus and is not supported by DNA analysis. We certainly do see a founder effect going on with respect to Eurasians after the migration begins 60,000 years ago, with leading geneticists suggesting as few as 200 individuals acted as the ancestors for all living Eurasian people. This reduction in genetic diversity is hardly surprising. And with that tantalizing statement, we leave you to contemplate the mysteries of our shared human history. Until next time, remain curious and stay questioning. Please subscribe, share, and check out our channel's other videos. Thank you and take care.